1 Corinthians 7:7 clearly states that we are all gifted with different talents. Some are good dancers, some are good teachers, doctors, some are good footballers, great musicians. The question is, have you ever discovered the talent you possess? If yes, what have you done for it? And if no, what are you waiting? Please discover that talent, explore it, and change the world. It is already stated that we have all different talents. Make use of your talent and change the world. Remember, by His stripes, we are healed. We are gifted. We are given the grace to live. You're welcome to yet another edition of OS e-learning platform, brought to you by OPERO STEPHEN. Before we continue, let's thank Jesus for the gift of life. Jesus in heaven, we thank you. Thank you for loving us. Thank you for sacrificing yourself for surely the love that you have for us. As OS e-learning platform, we can't continue unless you lead us, unless you guide us. Father, guide us. Give us the grace to explore our talents. 1 Corinthians 7:7 clearly states that we are given different talents, but at some point we really don't recognize them. Guide us to discover our individual talents. Jesus, guide us. Give us the wisdom, knowledge, and understanding to explore our talents. Guide us in this very presentation. Thank you, Jesus. All this we pray through Christ, the Son who lives and reigns within the unity of the Holy Spirit, one God forever and ever. Amen. We believe that wherever we pray, we actually receive through His name, Jesus. And in all the different sectors of faith and belief, we all believe through God who created us. Please don't forget to subscribe, like, comment, and share the video. So this presentation is particularly for those offering principal physics as part of their combination in A-level, and to start with, new A-level physics, senior 5, term 1. So the first topic of this term is measurements and the dimensions of physical quantities. And the competency, we agreed in the first presentation when we were talking about the topics to be covered in the course for 2 years, physics, principal physics, and each topic has a competency. And the competency for this very topic is the learner uses a variety of instruments to accurately measure physical quantities and applies the concept of dimensions to establish the relation between these quantities. So you should be in position to use all those gadgets in the physics laboratory: the ammeter, voltmeter, stopwatch, stop clock, vernier caliper, micrometer, screw gauge. Mention them. You should be in position to accurately use them to measure physical quantities. And these quantities include the fundamental and the derived quantities. The fundamental are mass, length, and the time. Then the derived range from pressure, temperature, range from viscosity, force, range from acceleration, velocity, range from very many perimeters. So we have very many of them, and each variable has its fundamental instrument used to accurately measure its quantity or amount. And should also be in position now to use the dimensional analysis to prove the relationship between the equations, between variables, and also to validate or to verify the consistency of these equations. So the learning outcomes are actually two, and the first one, measure a variety of physical quantities in the environment. with minimum errors. So the values, the attitude, the skill, the generic skills should be at your fingertips while manifesting, while practicing this. As you're measuring the value of this quantity, you are measuring time. You should measure time using a stop clock, but with minimum errors, with actually no error. However, because of other factors, we actually face some of these errors. Analyze the dimensions of a variety of derived physical quantities and use them to check the consistency of equations. So your values, your attitude, your understanding, your skills, your generic skill should be at your fingertips. So the requirements for a learner to achieve learning outcome 1, or the first learning outcome. So 1, you will have to brainstorm the fundamental and the derived physical quantities met in your previous studies. Kindly check the fundamental and derived quantities. Actually, this is senior 1, where we talk about the quantities in physics, the fundamental and the derived quantities. We'll also make a review on the concepts of scientific notation and significant figures. If you missed the presentation titled Significant Figures versus Decimal Places, please check and go through it, because it's a requirement here. It is a credential here, please. Measure a variety of physical quantities using appropriate instruments and state their accuracies, such as the vernier calipers, the micrometer screw gauges, etc. So can we put emphasis on this? Because sooner or later we shall be performing scientific investigations on determining electrical resistivity of a wire, and at some point we'll be required to measure the diameter of the wire, where we shall make use of a micrometer screw gauge. At some point we shall determine the refractive index of a glass block, and at some point we shall be required to measure the width or the length of that block. So at some point we shall make use of the vernier calipers, and so you need to be in position to accurately use these instruments to measure the length, to measure etc. You will use a stop clock, a stopwatch to measure the time. We will use a beam balance to measure the mass, and so on. So we need to be in position to use a variety of physical quantities appropriately and state their level of accuracies. Identify the sources of errors for a variety of measurements and devise means to minimize them. It is a credential here for you to hijack the first learning outcome. The sources of error, depending on what you're measuring. There are very many sources of errors along measurements of physical quantities using these gadgets, using these instruments. Then lastly, you should be in position to establish the accuracy of calculated values in a variety of situations. Requirement, credential for a learner to achieve learning outcome 2. Part A, explain the meaning of dimensions of a physical quantity. Part B, state the dimensions of the fundamental physical quantities and use them to determine the dimensions of different derived quantities like power, force, velocity, acceleration, momentum, pressure, moments, and so on. Check and verify the consistency of equations using dimensions, and also state the SI units of some of these quantities. Discuss the merits and the demerits of dimensional analysis. Well, dimensional analysis is more of the merits, but on the other hand, it has some limitations. That is why it is termed as a demerit at some point. But again, I don't want you to take this personal, as in dimensional analysis being a concept that has a disadvantage. It just has limitations. That's why at some point it is not valid. Dimensions of a physical quantity. What is this all about? Physical quantities are divided into two groups. One, the fundamental quantities, whereby these are quantities which cannot be expressed in terms of other quantities using any mathematical equations. For example, we have the mass, capital M, length, capital L, and time, capital T. These are fundamental quantities. In senior one, we even talk about the year when they derived this and in which country. Please check that literature. Check that literature. Make research. Derived quantities. And now these are quantities which can be expressed in terms of fundamental quantities, in terms of mass, length, and time. So derived quantities are also called dimensional quantities or derived quantities. So basically, these are quantities which can be obtained. Check here. Which can be obtained by combining. This is can be. Oh God. This can be. Let me change the ink. Which can be. Can erase this one. Which can be obtained by combining the fundamental quantities mathematically. Example includes acceleration, speed, power, force, distance basically is a fundamental because distance is length. Moment, momentum, acceleration, force, pressure, viscosity, velocity, etc. etc. Then we have those quantities that are not related to mass, length, and time. And the name basically is dimensionless or non-dimensional quantities. They include relative density, refractive index, logarithms, trigonometric ratios, mechanical advantages, mechanical advantage, of course, pure numbers such as 1, 2, 3, 4. Basically, these are variables or quantities that have no units. If you look at refractive index, has no unit. Logarithms. If you look at relative density, mechanical advantage, pure numbers 5, pi, 7, etc. Those variables do not have SI units. Therefore, you can't derive them using the relationship between mass and length, or length and time, or mass and time, or amongst mass, length, and time. So dimensions of a physical quantity show the way a physical quantity, in bracket derived quantity, is related to the fundamental physical quantities. Fundamental physical quantities of mass, length, and time. So we use the symbol square bracket. So this is the symbol we use. The symbol is for square bracket to represent dimension of a quantity. Examples. Find the dimensions for the following. Mass. The first three are fundamental quantities. We just have their standard dimensions, capital M, capital L, and capital T, respectively. And then for area being a derived quantity, we need to check on its relationship with the mass, length, and time. So we get to realize that area is length times width, whereby length is still length and width is also length or distance. So for that case, we shall have length times length, which is L times L squared. For volume, the same thing. It is actually length 3 times. Length times width times height. All these are distances measured in meters and actually length. So volume will be length times length times length and L cubed. Velocity This is the rate of displacement, rate of change of displacement, and that will give us the dimension of displacement divided by dimension of time. And displacement being distance moved but in a specific direction, and my interest is on distance, and that will be length over time, and that will be LT power negative 1. The indices will clearly show us how this is becoming a negative, how this is becoming a negative 1. So we get to realize that if I have 1 over t, 1 over t, remember power 1 is here, so this is like having a t raised to power negative 1. But remember there is an L here, L is there. So when L is there, then the whole thing goes back to LT power negative 1. That is for velocity. Please keep track of these dimensions because we are going to just use them in the next part. Acceleration, that is rate of change of velocity, and that means we shall have the ratio of velocity to time, and the dimensions of velocity, since we have it in the part F, and the dimension of time we have it in part C, we have to just substitute, and this will give us LT power negative 2. For force, force being mass times acceleration, so we shall take the dimensions of mass and also acceleration, and since for mass is capital M from part A, and for the acceleration LT negative 2, which is on part G, and that will give us a product of MLT power negative 2. Work done, force times distance. Dimensions of work done will be dimension of force times dimension of distance, and that will be M for mass, MLT negative 2 for force, and then distance L, and the whole thing will give me L, ML squared T negative 2. Power. Power is the rate of doing work, and that will be the ratio of work done to time. So I will split the dimension of work done to divide by the dimension of time, and that will lead me to ML squared T negative 3. Indices, please, indices. Check your indices, and if you miss that presentation, check, because it's required here. So that's why we say physics is related to mathematics, because in physics we have mathematics. Pressure, force over area. So I will take the dimension of pressure as the ratio of dimension of force to dimension of area, and that will give me MLT negative 2 over L squared, and that will give me ML negative 1 T negative 2. Indices. Kinetic energy, which is a half mv squared. So I will take the dimension of kinetic energy as dimension of mass times dimension of velocity, but velocity is squared. So I will ignore the half, given that a half is a dimensionless constant. And that will give me ML squared T negative. Now, after understanding or mastering the previous presentation or examples, let's try this out. Activities. Find the dimensions of the following: energy, tensile stress, impulse, momentum, tensile strain, Young's modular, density, potential energy, momentum. Please create more 10, and please prove yourself. Prove yourself by trying them out. Then I will just guide you on how you are to do this. First and foremost, first recall the definition of the variable at hand. If the variable at hand is momentum, what is the definition of momentum? We realize that momentum is the product of mass and the velocity. So it is mv, and the dimension of mass is there, dimension of velocity is there. Another thing, if the item at hand, if the quantity at hand is moment is the product of force and perpendicular distance from the fulcrum or point. So we are respecting force, of which we have its dimension, and also what? Perpendicular distance from the fulcrum. And distance is actually length, whose dimension is vividly known. So we prove this by recalling the equations connecting them with the fundamental quantities. Merits of dimensional analysis, we have three. We use it to check the consistency or validity of the equation. Two, to derive equations, and for us to do this, we have actually to possess an idea about the factors upon which a given quantity depends. The method of dimensional analysis can also be used to derive equations. We can derive this once the scenario gives you a variable, a quantity, and that quantity is depending on other quantities. You just relate that quantity to the other quantities it is depending on. Then we raise the quantities that the quantity is depending on to a certain exponent or power. We call it x, y, z. And then we have to find those values of x and y. Then we connect them to the original relation we generated. We also use this knowledge of dimension analysis to generate the SI units or the standard units, or to predict the standard units of some quantities. Demerits of dimensional analysis. I repeat, demerit does not mean dimensional analysis is bad. It actually, in this context, we are actually looking at the limitation, the boundaries of dimensional analysis. So, well, another advantage of dimensional analysis, it helps us to what? To eliminate wrong equations. Now that we can prove the validity of the equation, and if the equation is valid by dimensional analysis, then that equation probably might be, I'm using probably, might be correct, because at some point, not all dimensionally consistent equations are correct. So at some point, if they are not correct, we shall eliminate them, but cannot be used to prove the correctness of a particular equation. It does not provide any information about correctness of numerical factors such as a half, 2, pi, 9, 10, 20, etc. So how do we use the merit of dimensional analysis, which is checking the consistency, validity of equation? How do we use that knowledge to check the consistency or the validity? How do we use this to prove whether the equation is correct or wrong? We shall use this example. But before that, we need to note something, that for a correct equation, the unit on the left-hand side should be balancing with those on the right-hand side. This implies that the dimensions on the left-hand side should balance with those on the right-hand side. And all correct equations, let me underline this, all correct equations should be dimensionally consistent. Please, this word is very important. As long as you call that equation to be correct, when I subject it to this test, when I subject it to dimensional test, dimensional analysis, it must stand. It must be consistent. It must be correct. However, not all dimensional consistent equations are correct. Now, that's where we bring the other aspect of boundary or limitation of dimensional analysis. At some point, it does not prove the correctness of the equation. However much the equation can be dimensionally consistent. So, if you look at the equation, V is equal to U plus AT, well, it is a correct equation. But again, when I subject it to dimensional analysis, it is correct. It is dimensionally consistent. However, when I say V squared is equal to U plus AT, that equation is not correct. That equation is not correct. V squared is equal to U plus AT is not correct. However, when I try to subject it to dimensional analysis, at some point, I might get the same answer, which is dimensionally consistent. And I will prove you with some examples here. And you will see that some equations are dimensionally consistent, yet they are actually wrong. So that is a limitation. That's why now dimensional analysis becomes a demerit or a disadvantage at some point. So let's try to test the validity of these equations using the dimensional analysis. S is equal to ut plus half at squared. Left hand side is distance L. Right hand side, I have ut plus half at squared. So ut is LT power negative 1 times t plus at squared. Half I will ignore it. Then I will have, because the dimensional is constant. So acceleration, we have it LT negative 2 and time still t, but time is squared at this level. So I will have 2L. But now this 2 is a dimensionless constant. I can still ignore it. Actually, I do not have that 2. I will cross out this 2, and the whole thing will just be L. That L. Now, if you compare the left-hand side with the right-hand side, on the left-hand side I have L, and the right-hand side I still have L. So that one means that the equation is dimensionally consistent. Since the dimension on the right hand sides are equal to the dimensions on the left hand side, then the equation is dimensionally consistent. Number 2, left hand side we have LT power negative 1. Right hand side, simplifying everything. These variables you have them already. We are just substituting. I will have LT negative 1. Left hand side is equal to right hand side. Left hand side is equal to right hand side. So since the dimensions on the right hand side is equal to dimensions on the left hand side, then the equation is dimensional. Number 3, V is equal to U squared plus a half AT. This equation is wrong. Can we prove whether it is dimensionally consistent? Let's prove. Left hand side I have LT negative 1. Right hand side I have LT squared. So L squared T negative 2 plus LT negative 1. Now if you check critically on the left hand side, if you critically check on the left hand side, I have something of this caliber whereby I can't add it. Then on the right hand side I have that, then left hand side I have LT negative 1. So they are not actually equal, so it's not consistent. Actually, the truth is an equation that does not prove the validity using dimensional analysis is wrong, because dimensional analysis helps us to prove. However, it is a limitation that it does not give the correctness. But at some point, if you subject wrong equations to dimensional analysis and it gives you left hand side being not equal to right hand side, that equation is automatically wrong. However, on the other hand, even wrong equations can give dimensional consistency. So you need to be careful with that. So we can see that the dimensions on the left hand side are not equal to dimensions on the right hand side. Therefore, the equation is incorrect, or it is invalid. V squared is equal to TL over M, where T is tension, L is length, and M is mass. So left hand side I have L squared T negative 2. Right hand side I simplify everything because I know tension is force, and then length is L, then mass is capital M. I have L squared T negative 2. So this equation is correct, and therefore it is dimensionally consistent. Number 5, V squared is equal to U squared plus 2AS. Physics, all students of physics, all the mathematicians, you must be memorizing this, because we apply this in mathematics, the mechanical part of mathematics, and also the linear motion aspect of it. We make use of linear equations of motion, the equation of motions under linear motion. So we want to prove the left hand side, it gives us L squared negative 2, right hand side L squared negative 2. So the equation is correct and also dimensionally consistent. Check on this one here. Left hand side I have L squared T negative 2. The right hand side I have L squared T negative 2. Aha. If you look at this equation, basically, the equation sounds to be correct. However, okay, basing on the dimensional analysis on the left-hand side and the right-hand side. But again, if you check this equation, try to compare it with this equation. So if a student states this equation number 6 and is trying to relate it to this, then we shall say this equation number 6 is wrong and this one is correct. However much both of them are dimensionally consistent. So this is what we are saying, that this question is wrong because we can't give an explanation for this 9 and 6. Well, for these two we can give an explanation because as you're deriving these equations, you under mechanics, under linear motion, as you're deriving at some point we'll get these two. But as you're deriving this equation, you will never get a 9, neither will you get a 6. So this equation is wrong, however much it gives dimensionally consistent condition. So this vividly shows us that not all dimensionally consistent equations are correct. Not all dimensionally consistent equations are what? Are correct. So that's why we shall say, well, the dimensions on the right hand side are consistent with those on the left hand side, which is okay. However, it can be seen that the equation is not correct because the wrong values for the constants 9 and 6. This is due to the fact that the constants 9 and 6 are dimensionless, and therefore dimension analysis can be used to eliminate wrong equations but cannot be used to prove the correctness of the particular equation. So that's a limitation. That's why it is a demerit to use dimensional analysis. Since it does not provide any information about the correctness of the numerical factors such as 9, 8, 2, etc. as a half, pi, etc. as -3, 5, we only use it to eliminate wrong equations by identifying the correctness using other approach, the correctness of the equation. So let's try this sample worked out item. I try to generate this for us to negotiate, to connect the knowledge of dimensional analysis. And please, after doing this, you will try other scenario-based items down there, about 6 items. And also I will project you to make research on this topic to expand your understanding. Make research on different perimeters, the real life applications. I have much, yes, I have some sample here. Try to digest that. So the example we have here, at St. Lucifer Secondary School in Namaingo, students are preparing for the upcoming National Physics Exhibition. One of the groups, led by a student named Akena, is investigating the motion of a simple pendulum made using local available materials, a small stone tied to a banana fiber string. They are trying to understand what affects the period T of oscillation. That is the time it takes for the pendulum to complete one full swing, back and forward. Akene believes that the period might depend on the mass m of the stone, the length L of the stone, or the string, and the acceleration due to gravity G, which is roughly 9.8, of course, in Uganda. Now, this acceleration is on the Earth. And since Uganda is on the Earth, then we shall use that acceleration. So since Uganda is on the earth, we shall use that very acceleration 9 point. And this is one of the experiments you do in the lab to perform, to investigate the acceleration due to gravity. The group wants to create a mathematical model or formula that predicts how time, period, changes with those variables. However, they are unsure which variable really affect the period and how. They have asked you as a school's top physics student to help guide their investigation. Task: using your knowledge of physics, that is in particular dimension analysis, help the group. So my expected response: I will let the period t depend on length L, mass M, and the acceleration due to gravity G. Now since I don't know the degree or the power on the L, M, and G, I will just let the powers or the exponents be X, Y, and Z. So to remove the dimension, to remove the proportionality symbol, I will equate it and include a constant of proportionality. And that constant is actually dimensionally consistent. Dimensionless. It is a non-dimensional perimeter. So where K is a dimensionless constant of proportionality, and then using dimensional analysis, when I look at the left-hand side, since it is a period, I will have T. The right-hand side, I will use the dimensions for L, length, mass, and acceleration due to gravity, and everything will lead me to L power X, M power Y, L power Z, T power negative 2Z on simplifying. So here I will apply the rule of indices. So my L, since I'm multiplying this X and this Z, I will add them, then I will have X plus Y as the power. Then my M will remain with the power Y. My Y will remain there. Then my T, I will still remain with negative 2Z. Negative 2Z. Now I will come on the left hand side and also identify my L. So if I look at the L, I don't have a L here. It's like we had L power 0. It's like we had L power 0. Then M, we don't also have M here. It's like we had M power 0. So I'm just going to equate the powers. Then on T, I have power 1. So I will just equate the powers of the same dimensions on the left hand side to the powers of the same dimension on the right hand side. So if you look at these dimensions, I will have M, L, and T, and so I consider one by one. M, on the left hand side the power of M is 0, then on the right hand side the power of M is Y, so 0 will be equal to Y and Y will be equal to 0. For L, the power of L is 0 on the left hand side, and on the right hand side the power of L is actually X plus Y, so I will equate 0 to X plus Y and my Z, X plus Z, sorry, and then my Z will be equal to negative X. And then for T, on the left hand side the power is 1, or the indices, the exponent of T is 1, and then on the right hand side the power of T is negative 2Z. So equating 1 to negative 2Z ultimately gives me Z as negative 1/2, and thus when I want to get X, I will use the knowledge of the second equation, and my X will be a positive 1/2. So by substituting my X as a positive 1/2, Y as 0, and Z as negative 1/2, using the rule of indices, I will not repeat that. Please, if you missed indices, check in the first presentation on mathematics, principal mathematics. So simplifying everything, I get the equation connecting period t with length and also acceleration due to gravity as t is equal to k square root of L over g. So this is the mathematical model or formula or equation that can help these students to predict how period changes with mass and length. And this is t is equal to k into L over g, where, please write that one, where k is a dimensionless constant of proportionality, or is a dimensionless constant. That can be 1 and all that. So from here we can vividly see that the period depends on the square root of length. Taking a situation where acceleration due to gravity is a constant value, whose value is approximately 9.8 meters per second squared. So when we increase the square root of length, we are actually increasing the time taken for the pendulum bob that was made using the local resources. The time taken for it to make complete cycles, the time taken for it to make complete cycle to increase. In other words, it will make few complete cycles when the length is increased, the square root of the length is increased, and therefore it will take long time to make those cycles. So the period varies with the square root of the length. Longer pendulums swing more slowly, meaning the square root of length increased. It takes more time to make a complete cycle. So it swings slowly because it has a longer period. And the shorter ones swing more quickly because it has a shorter period. Thank you. Now that you've acquired some knowledge, can you please try out these sample items? Don't forget to like, subscribe, share. Explore this. Try them out. Thank you for watching. Thank you for listening. May God protect you. May God keep you alive. We meet again in the next presentation. Don't forget, to discover the talent in you and use that talent to change the universe. We meet.